Okay, so let's go ahead and get started on this. Whenever you are solving here, if I tell you to solve this equation and let x equal 1, okay, that means that in my equation, I'm going to replace x with 1 and solve it and see what I get for y. Okay, so y is equal to 4 times 1, which is 4, plus 3. So you should have got that y is equal to 7. Okay, so all you did there was you substituted in 1 for x and then solved the rest and see what you got. Okay. Same thing for the second one. Okay. If they're telling you that y is equal to 3, that means right over here where you see y, replace that with 3, and then solve the rest of the equation and see what you get for x. So 6 minus x equals 8. Okay. If I subtract 6 from both sides, that gives you negative x equals 2. Okay. I don't want negative x or negative 1x. I'm going to divide by negative 1. That's going to leave me with x equals negative 2. Okay. Was there questions about solving either one of those or how to do that? Okay. So what we're going to be doing today is the same type of thing, okay, except for instead of plugging in just a single number like x equals 1 or y equals 3, you're going to be plugging in an expression. So it might say like 1 plus x or 3 minus 2y. You're going to be substituting in an entire expression instead of just one single number. And this is what we call solving using substitution. Okay. So looking at section 6.2, and I am recording this so you guys can go back and watch it if I go a little fast, and there will be a copy of these notes available for you on Canvas. Okay, so we're solving systems of equations still, but this time we're using substitution. So we're still solving the same types of equations, but instead of graphing them and seeing where they cross, because obviously that's not always ideal, this is a method to find an exact solution of a system without a graph. Okay, so the first thing that we're always going to do when we're using substitution is we're going to solve at least one equation for one variable whenever this is necessary. So we want one of our equations to say y equals everything else or x equals everything else. So you want one of the equations to be solved for one variable. Sometimes they already have this done for you. Sometimes you actually have to do this step. Okay, so out of your two equations, you want one to say either y equals or x equals. Okay, now we are going to substitute the resulting expression into the other equation. Okay, so this is basically what we're doing on the Bellware. We're substituting in a number for a variable. We're going to be substituting in an expression for the variable. Okay, and then we're going to be able to solve. So instead of having x and y in the same equation, it's just going to leave us with one variable. Okay, so now once we have one of our values, we can sub that into our equation and solve for the other variable. So we're still going to get an ordered pair x, y as our answer. It's just a different way to go about getting x and y. Okay, and sometimes the step-by-step doesn't necessarily make sense until we actually go through an example. Okay, so if that's not really that clear right now, okay, hopefully it will be here in just a minute. Okay, so again, we're going to be solving one of our equations for one variable, substituting that in, okay, and then being able to find our other variable, either x or y, once we get our first value. Okay, and again, our ordered pair is always, or our answer is always going to be an ordered pair. It's never going to be just one number. It's always going to be an x and a y. Okay, so let's look at an actual example here and put this to use. So you've got two equations, y equals 2x plus 1, and 3x plus y equals negative 9. Okay, so if I go back and look at my first step here, okay, I need one of my equations to be solved for either x or y. Okay, I have that right here. Okay, y is equal to 2x plus 1. Okay, this is already solved. It says y equals. Okay, that's what we want right here. Okay, so on this substituting step, okay, for whatever reason, this is always difficult for some people. Okay, so don't worry if you don't get it the first time. On this substituting step, okay, you are substituting this expression into this bottom equation down here. So if y is equal to 2x plus 1, that means down here, this y is also equal to 2x plus 1. Okay, so I'm going to rewrite this second expression by substituting in that expression 2x plus 1. So I still have 3x, but instead of plus y, I'm subbing in what y is equal to, 2x plus 1. And then it's still equal to negative 9. Okay, is there any questions about how we substituted that in there? Just replacing y with what y was equal to? So now at this point, the reason why we do this is because now I have only x's in this second equation, and I can combine like terms. So 3x and 2x I can do adding there because it says plus. Okay, that gives me 5x. I still have a plus 1, and it's still equal to negative 9. Okay. Now you should be able to solve this. It's just an algebra expression at this point, or algebra equation. So subtract 1 from both sides. You're going to get 5x equals negative 10. And then you'll divide by 5 so you can figure out what x is. Negative 10 divided by 5 is going to give me negative 2. Okay. Now, this is only part of our answer right here. Okay. But this part is very important because I also have to figure out what the y value is of the ordered pair. So if I know that x is equal to negative 2, I still have to figure out what y is. Okay. Well, all the way back up here, when I very first started, I know that y is equal to whatever 2 times x plus 1 is. Okay. If I know that x is equal to negative 2, I can go back up here where I see x and sub in negative 2 to figure out what y is. Okay, so we're going to do that now. So I've got y equals 2 times x, or 2 times whatever we found for x, negative 2, plus 1. All you have to do there is solve that value. Okay, that's basically exactly what you did on the bell work. I said solve this equation whenever x equals this. Okay, that's what you did on the bell work. Okay, so you substitute that number in. Okay, y is equal to negative 4 plus 1, or y is equal to negative 3. Okay. The most important part of this is once you've figured out what x and y are, you have to write this as an ordered pair. So your final answer is not x equals negative 2, y equals negative 3. It's negative 2, comma, negative 3. Okay. Now, I know that was a lot of stuff. So are there any questions right now? We're going to do several of these examples. All right, let's do a second one. So over here on the right side, you have 2x plus 5y equals negative 1, and y equals 3x plus 10. Okay, so we're going to first look and see if we have an equation that's already solved, which we do. Okay, this equation right here is ready to go because it says y equals 3x plus 10. Okay, so if y is equal to 3x plus 10, up in this other equation where I see y, I'm going to substitute this in there, this 3x plus 10. So I'm going to rewrite that other equation, so 2x plus 5, but instead of y, in parentheses, I'm going to put but y is equal to 3x plus 10. Okay, now, it is important that you put that in parentheses because you have to multiply that by 5. Okay, it's 5y or 5 times y, so it's 5 times that 3x plus 10. So whenever I start to solve this, I need to do distributive property first. So 15x plus 50. Then I can combine like terms. So 2x and 15x is 17x. Plus 50 equals negative 1. Okay. Then you can solve this like a regular equation. Minus 50 from both sides. You get 17x equals negative 51. Okay, then I'm going to divide by 17. If I take negative 51 divided by 17, I'm going to get negative 3 for x. Okay, this is part of my answer right here. Okay, don't do all of that work and think that you're done and forget to go back and find what y is. Okay, that's only part of your ordered pair. I have to take this x equals negative 3, use that to figure out what y is. Okay, so up here that we said y equals 3x plus 10. Okay, which means that y is equal to 3 times x, or negative 3 plus 10. Again, that's exactly what we did on the bell work. Okay, subbing in that value and solving. So negative 9 plus 10. You should get that y equals positive 1. Okay, So you know x equals -3. You know that y equals +1. Write that as an ordered pair. X and then y, so -3, comma, 1. Any questions about either one of those examples that we just did? Anything that you're not sure where the number came from, or you're not sure how we got from one thing to the next? Anything we're unclear about right now? Okay, so now we're going to be looking at using substitution still, okay? But when I go to see if one of my equations is solved, okay, we'll notice that neither one of these equations say x equals or y equals. Nothing is set up to solve, okay? Now, does anybody have any idea which one of these would be easier to solve? Does anybody want to unmute themselves and take a guess at which one of these would be easier to solve for x or y?
The top one.
Why the top one? That's right, though.
Because it has even numbers.
Okay, would you solve it for x or for y?
For x.
Okay.
Because it's the only one that has x by itself.
Right, so look at your set of numbers and see if you have something that's kind of like this one that's just x, okay, and that's going to be one that you can actually solve, okay, so that was right there. We're going to take this top equation, x plus 2y equals 6. I'm going to solve it so it just says x equals. I can do that in one step by just subtracting 2y from both sides. X equals 6 minus 2y. And now I have a new top equation. So I'm just going to mark this out up here because I've got a new top equation right here that I don't need anymore. Okay. Now, once we have this solved, I know that x is equal to 6 minus 2y. Okay. So over here in this other equation, okay, I can replace x with 6 minus 2y. So you're always replacing with whatever this is equal to. Okay. If it says x equals, that means you're taking x out of the other equation. If it says y equals, you're taking y out of the other equation. Okay. So instead of 3x, I'm going to have 3, and then whatever x was equal to, okay, 6 minus 2y, then minus 4y equals 28. The rest of the equation always stays the same. Okay. Is there anybody or any questions about solving that part or substituting that piece in before we move on? Good. Okay. So now we're going to solve this for y. So start with distributive property. 3 times 6 is 18. 3 times minus 2y is minus 6y. I still have minus 4y and equals 28. Okay, now combine your y's, negative 6 and negative 4, that's minus 10y. Okay, solve this, so subtract 18 from both sides. And you get negative 10y equals positive 10. To finish that, we're going to divide by negative 10. And we figure out that y is equal to negative 1. Okay. Now again, don't do all of this work and then stop and say that y equals negative 1 is your answer. You still have to solve and get an ordered pair, okay? Which means if I know that y is equal to negative 1, I need to go back to this equation that I first substituted in to figure out what x is, okay? So we said that x was equal to 6 minus 2y. So that means I can say x is equal to 6 minus 2 times negative 1, okay? So substituting in that value that you found, okay, to find your other variable. So 6 plus 2, okay, so then that's going to give me x equals 8. I found x and I found y, so now I can write my ordered pair, okay, x and then y, make sure you put it in the right order. Okay, so it would be 8, negative 1. So what you're telling me here is that if you solve this by graphing like we did in section 1, that would be the ordered pair where they cross. Okay, if you go back and you graph any of these, that's going to be the ordered pair where they cross. This is just another way of us to solve these without having to put them on a graph. Okay. So is there any questions about that example or how to start that one off or anything like that? Okay, So we have the same idea for this one. Neither one of these is solved. Okay, does anybody want to tell me which one of these is going to be easier for me to solve?
The bottom one.
The bottom one.
Y is by itself.
Right, because y is by itself. Good. So if y is by itself, like it is on the bottom, there's no coefficient or number that's out in front. That's going to be the one that we want to solve for. So my one step to get y by itself here is just going to be plus 3x on both sides. So that I now have y equals negative 13 plus 3x. Okay, now that's the equation that we're using. Okay, don't get confused here. Okay, that's the equation that we're using along with this top one. Okay, so I know that y is equal to negative 13 plus 3x. So up here, since it was y equals, y is coming out. So I still have 4x plus 5 times the value of y, negative 13 plus 3x, equals 11. Okay, so now when I do the distributive property, I'm going to take 5 times negative 13 and 5 times 3x. Okay, so if I take 5 times negative 13, double check here so I don't write the wrong thing, my brain's not working, negative 65, okay, then 15x and equals 11. Okay, combine any like terms, so 4x and 15x, that's 19x. I still have minus 65 and it equals 11. Okay, now we're solving for x at this point, so I'm trying to get that by itself. Okay, so we're going to add 65 to both sides. So 19x equals 76. Okay, then we're going to divide by 19 on both sides, and that's going to give me 4. Okay, so once you've done the actual substitution part and got that value into the other equation, it's just the regular solving. That part should not be anything new. Okay, you should not have any trouble getting x equals 4 once you've substituted in your value of y. Okay, now you still have to figure out, okay, x equals 4. Okay, you still have to figure out what y is, so we're going to go back up here. Okay, y was equal to negative 13 plus 3x. That means negative 13 plus 3 times 4. Now when I solve this, I get negative 13 plus 12, which ends up being negative 1. So I know x is 4. I know that y equals negative 1. When I go to write my ordered pair as my answer, it's always x and then y, so 4, comma, negative 1. Okay, the biggest thing is don't forget to write your answer as an ordered pair. Okay, a lot of people like to put x equals 4, y equals negative 1. The answer is an ordered pair. Okay, it has to be written as an ordered pair. Okay, are there any questions about that? All right. So we're going to use substitution here again to solve the system of equations. Okay, as you can see, this one has one that's already solved for us. Y equals 2x minus 4. Okay, so where I see y in the problem in the second one, okay, that's going to be replaced with 2x minus 4. Okay, so whenever I start solving this, okay, again, I'm substituting in for y, and then I'm going to have to do the distributive property to start solving this. Okay, so negative 6x plus 6x minus 12 equals negative 12. Okay, what's going to happen whenever I combine like terms here?
It's going to be no solution.
Close. Okay, these are going to cancel. Okay, you're on the right track here. Okay, but what I have left is actually true. So what do you remember about things that used to be the variables drop out and what you have left is true? What kind of solution was that? Anybody remember what that was called? Does infinitely many sound familiar? Okay, so whenever you're solving this, okay, if your variables cancel out and what you have left right here is a true statement, okay, negative 12 equals negative 12, that is true. Okay, that means that you have infinitely many solutions. Okay, that means if I was going to graph these are both the same line. Okay, they're going to be one on top of the other. That means that every single point that is in the first equation is every single point also in the second equation. Okay, so if what you have left is true, okay, that is going to be an example of infinitely many. Any questions about that? Okay, so on the second one, I have 2x minus y equals 8 and y equals 2x minus 3. My second equation is already solved. Okay, so I have a 2x minus 3. Now, one thing I want to point out right here whenever you are solving this, okay, again, is to put this in parentheses because it's 2x minus both of these things. If you just put minus 2x and then minus 3, okay, that's not going to be the right thing because you're actually subtracting the 2x and you're subtracting a negative 3. Well, if you subtract a negative 3, it becomes plus 3. Okay, so make sure you pay attention to that part. Okay, it's not really going to make a difference in this particular problem, but it could make a difference in others. Okay, so in this situation, 2x minus 2x is going to cancel, okay, and I'm left with 3 equals 8. Okay, 3 is obviously not going to be equal to 8. Okay, this situation is false. Okay, so that should tell you that if something is not true whenever you get to the end, that the other option here is that these are no solution. Okay, so whenever I graph these two lines, okay, they're parallel to each other. They're never going to cross, okay, and they're parallel, so there is no solution for them to meet at. Is there any questions about knowing if it's infinitely many or if it's no solution? Okay. Last one here is a word problem that we're going to look at. Okay, it says, as of 2009, the New York Yankees and Cincinnati Reds together had won a total of 32 World Series. Okay, the Yankees had won 5.4 times as many as the Reds. How many World Series had each team won? So I don't know if we have any Yankees or Reds fans in here or if anybody even watches baseball. Okay, but these are both two teams that do have a lot of championships, okay, especially the Yankees. So the Yankees and the Reds together had a total of 32 World Series. We need to write an equation for that. Okay, so the Yankees plus the Reds, if I add all of their titles together, okay, it's 32 total. Okay, if I take all the Yankees trophies and all the Reds and add them together, it's going to be 32. Okay, then it tells me that the Yankees won 5.4 times as many as the Reds. So the Yankees titles, okay, were equal to 5.4 times as many as the Reds, which is basically just times R. So then they want to know how many World Series had each team won. Okay, so if I'm looking at my two equations here, we do have one that's already solved. We know that y equals 5.4r. Okay, so I'm going to take my 5.4r. It's y equals, so that's going to go in up here for y. Okay, so let's do that substitution. Okay, 5.4r plus r equals 32. Now, when you go to combine your like terms here, 5.4r plus r, that's like a 1. So add their coefficients. So 5.4 plus 1 is 6.4. Okay. Now, even though it's a decimal, solve it the same way. Don't freak out because it's a decimal. Okay. Divide by 6.4. So then I'm going to take 32 divided by 6.4, and I'm going to find that the Reds have won 5 World Series. Doesn't seem like a lot, but there's still some teams that have 0. Okay, so the Reds have 5 titles. Okay, so if I want to know how many the Yankees have, okay, let's go back up to here. Okay, take our 5 and sub it into what we had up here. Well, actually, you could do here, either one. Okay. So Yankees is equal to 5.4 times R, or you could figure out 5 plus what number gives you 32. Okay, I'm going to go with this second one here. Okay, if I take 5.4 times how many titles they had, 5. Okay, I'm going to figure out that they have won 27 titles. Which again, if you know anything about baseball, you know that the Yankees obviously probably have a lot of titles. Okay, so we've got the Yankees have 27 and the Reds have 5. Okay, this is the only time is an application problem like this where you don't have to write it as an ordered pair. Okay, they want to know how many World Series had each team won. Okay, the Reds had 5 and the Yankees had 27. Okay, you do not have to write this as an ordered pair because it does not designate like what's X and what's Y. Okay, so if it's an application problem like that, or how many of each is there, okay, there's no ordered pair for that type of answer. It's just what's happening for each situation. Okay. Are there any questions about solving using substitution? Anything that we're not sure about? Okay, so we are going to have an 8-question homework assignment over this. It's on page 347. Okay, you have 9 through 21 odds, and then number 31. Okay, so starting out on this, okay, you are going to have some that are already solved for you. Let me see here, I'm on the wrong section. Okay, so starting out, you're going to have some that are solved for you, just like we did on the notes. Again, so if you need to go back and watch this is recording, so you can go back and see it again. You'll have a couple of examples where an equation is already solved for you. Okay, and then you'll move through the questions and start to have to solve some like on your own. Solve it for X or solve it for Y like we did on the second examples. Okay, and then number 31, okay, is just going to be like a write out and explain type problem. Okay, so again, this is available in your online book if you don't have your textbook. Are there any questions right now?